All right, welcome. So today we're going to go through an introduction to Kubernetes. We're going to essentially set up a web-based development environment where we can have a cluster where we can test our different containers locally on our environment. This is just a kind of an introductory course. We're not going to get too much into any of the cloud-based Kubernetes or deploying our containers to the cloud this time. That will be in a future class. This is just to kind of get your taste buds wet with Kubernetes and moving forward with our discussions about containers. So today's agenda, we're going to discuss what Kubernetes is. We're going to look at the overview of the architecture and what are some of the ways to learn Kubernetes. You can do it yourself through your little online tutorials. Essentially go through this little tutorial demo that I put together for us today. There's some other places online where you can go to kind of do some sandbox type testing with Kubernetes. And then we're going to walk through a demo of actually setting up a local development environment with Kubernetes using Docker and kind of continuing our discussion from our introduction to Dockers. So what is Kubernetes? Well, Kubernetes, or K8 for short, is an open source system for automatically deployment, scaling, and management of containerized applications. So these are like your Docker containers. Its architecture is very similar to what we saw with Docker, except here we have a Kubernetes master system that essentially acts as your cluster environment, which handles all your node interfaces. And as you see up at the top here, we have our image registry like we did with Docker. And there is an API that sits on top of Kubernetes that allows us to communicate with the Kubernetes either through the Commandline interface or through a web user interface that we'll see today. Before we get into the demo, though, let's look at some of the ways you can actually experiment with Kubernetes. So they have 3 online features. There is Kubernetes Basics, Katacoda, and Play with Kubernetes. The Kubernetes Basics is essentially introduces you to 6 common Kubernetes workflows, where each section walks you through a browser-based interactive exercise complete with their own Kubernetes environment. So you actually build your own Kubernetes, or essentially you have your own sandbox in the cloud. You essentially work through it within a browser. Katacoda is an online playground equivalent of an environment used in Kubernetes Basics. However, Katacoda also provides more advanced tutorials such as liveliness and readiness health checks, which are skipped in the basics because it's basics. And then we also have Play with Kubernetes, which is a playground that allows users to run K8 clusters in a matter of seconds. It also gives the users the experience of having a free Alpine Linux virtual machine in a browser, where under the hood, you have essentially a Docker in Docker being used to give the effect of a multiple VM or PC interface. Before we really start talking more about Kubernetes, let's talk about some of the keywords or some of the terms that are used with Kubernetes. We're going to be talking about these a lot through the demo. So I kind of wanted to spend a moment and talk about the definitions of these before we actually rattle them off throughout the demo. So first we have a pod, which is a basic building block of Kubernetes, and it's the smallest and simplest unit of the Kubernetes object model that you create or deploy. So a pod essentially represents a running process on your cluster. The service in Kubernetes, a Kubernetes service is an abstraction which defines a logical set of pods and a policy by which to access them, sometimes called a microservice. The set of pods targeted by a service is usually determined by a label selector, which you'll see a lot of in our demo today. Volumes, by definition, are like hard drives. Volumes are essentially a directory, possible with some data in it, which is accessible to the containers in a pod. However, unlike Docker, a Kubernetes volume has an explicit lifetime. So the volume essentially sticks around for the lifetime of the pod that encloses it. So as long as the pod is active or it's installed, the volume exists. The moment the pod is destroyed, the volume goes away. Some supported volumes that Kubernetes uses are the AWS Elastic Block Store, Azure Disk, Flocker, Git repo, and Storage OS, just to name a few. And then lastly, we have the Kubernetes control panel. This is where Kubernetes maintains a record of all the Kubernetes objects in the systems and runs continuous control loops to manage those objects' state. Now, the control panel UI interface that we were talking about when we saw the architecture picture, where you can use the UI to talk to the API to talk to Kubernetes. So you can use the Kubernetes control panel, or you can also use the command line interface tools. So you can use either. You'll find that the control panel is a lot easier and nice, visually pleasing to work with. And it's pretty straightforward. Anything you can do on the command line, you can do in the GUI, the control panel, and vice versa. Some requirements. So before we actually get started with Kubernetes, we need to kind of set the groundwork. We need to install a few pieces of software, some tools before we can actually do anything. So to start with, we need to install hypervision. So we need to download one of the standard hypervision tools like VirtualBox, VMware, Fusion, or HyperKit. I typically prefer using VirtualBox because I tend to jump around a lot between Windows, Mac, and Linux. And VirtualBox essentially supports all three operating systems. So there's not a lot of differences between the different operating systems. So if basically you learn VirtualBox on one, you're comfortable using it on the others. Next, we need to get kubectl. Kubectl is essentially the Kubernetes command line tool. It's used to deploy and manage applications on Kubernetes. With it, you can inspect cluster resources, create, delete, and update components. You can look at new clusters and bring up example applications. Exactly the same things you can also do with the control panel. MiniCube. We will also need to install MiniCube locally. MiniCube runs a simple single-node Kubernetes cluster inside a virtual machine. This cluster is fully functional and contains all the core Kubernetes components, a perfect option for developers to use for local applications development. And then finally, Kubernetes recommends if you plan to run your MiniCube cluster as part of a local development environment, you will want an independent Docker instance to support your workflow. This allows you to create containers and push them to a container registry. We will be using Docker in today's demo, but we will not be going into much detail on Docker itself. So I recommend going out to our Vimeo feed and watching our video on an introduction to Docker for more details on setting up and using Docker. So today's demo, we're going to essentially set up a local Kubernetes instance. We're going to install the necessary tools that we just talked about. We're going to create our cluster. We're going to run a simple Hello World app to test our install. And then we're going to generate a sample Spring Boot application. We're going to then Dockerify that Spring Boot application. We're going to create a Kubernetes deploy file. We're then going to deploy our app to Kubernetes. We're going to explore the app and look at the command line options for viewing the app once it's deployed. We're then going to expose the app so that we can actually interact with the application, similar to like Docker, where we have to actually map the ports to connect to the Docker instance. Otherwise, it's essentially behind like a firewall. You can't actually access it unless you expose it to the world. And then finally, we're going to discuss some of the options and settings you can do in your deploy file to scale and update your application. So that's it for the slides right now. So we'll jump out to our demo here. And let's see where it is. All right, so first and foremost, I've already installed Docker, so I have my little Docker instance running up here. And to make sure that it's working from the command line, I can type Docker, and it shows, hey, Docker is there. If I do Docker PS, I have nothing running. So Docker is there, it is running, but nothing is deployed. So then the next thing I need to do, and I also already have VirtualBox installed. It's down here. So those two pieces, you can get to the download files for Kubernetes. It's kubernetes.io. Docker is docker.com, VirtualBox, virtualbox.org, and our Vimeo channel is vimeo.com/developer, and there's the introduction to Docker. So those are that's all I need for the browser for now. So the first thing we need to do is we need to install the command line tools kubectl. And to do that, type sudo curl -lo And here is the URL to get the Kubernetes, HTTP, storage, Google. This will all be in the blog and the show notes when I post it online. So for now, just enter in our sudo password. It'll take a minute to download. And once it's finished, we then need to make it executable. So we change mod to executable for kubectl. And then we need to move it to our user local bin. So move Kubernetes CTL to user bin. And now if everything went well, we should be able to access kubectl, which we can. And if you notice, kube-help is the same as just typing in kubectl. And if you want more information on each of the options, you can specify the option and then help. So we have basic things like create, expose, run, get, explain, edit, delete, rollouts. We'll touch on some of these as we go through the demo here. Okay, next we need to install the MiniCube. Same kind of setup. We do a CRUL to download it. However, with the MiniCube install, you have to actually set the executable and set the path at the same time. I'm not entirely sure why, but when I tried to do it in pieces, it told me it had to be done this way. So this is the way we do it. So now we're downloading the MiniCube, and it essentially did the same exact steps that we did for the kubectl. So we downloaded the file, we set it as an executable, and then we moved it to user local bin. All right, so now MiniCube should be installed. So if I do MiniCube, boom, we have the commands for MiniCube. And we're going to skip the Docker installation because it's already there. So now the first thing we want to do is we need to actually start our cluster environment. So let's make sure everything is working. So we do MiniCube start. It's going to start your local Kubernetes cluster. It's going to spin up a VM. This takes about a minute, maybe a minute and a half. If this is your first time running MiniCube, it will have to actually download the MiniCube ISO for your VM. Since I've already run this once, it's already downloaded that file. I tried to speed this up a little bit before we did our actual demo today. So when you do this yourself, it will take a little bit longer than you will see here. But don't fret, that's what it's supposed to do. The second time you run your MiniCube, it'll run just as fast. Here it goes. So it started VM. It's built the VM. It's getting an IP address. It's now moving any files you have deployed to your cluster, setting up your security and your certificates, also setting up your kube config file, starting any remaining cluster components, and now it's loaded. So we can verify it's loaded by checking the IP address of our MiniCube instance. And there it is, 192.168.99.100. If we actually want to use the dashboard or view the dashboard, we do MiniCube Dashboard. It will take it a second. So it will open up the dashboard. This typically takes about 30 seconds to a minute to fully instantiate the VM for the control panel to be viewed. So while we're waiting for that, let's go ahead and install our first Kubernetes pod. So we're going to use kubectl. We're going to run their hello MiniCube image. We're going to do image k8s. Remember that's short for Kubernetes.gcr.io echo server. So it's essentially just a basic echo. And then we're going to use assign it to port 8080. Okay, it's been created. It's going to take a sweet time. Well, that's setting up. We're going to now expose the development hello MiniCube on the node port. And now we should see our pod deployed. So here's our hello MiniCube. It's running. If you're dealing with Docker, that would be your container. And then we can check out a little more detail about the Hello Minikube by doing describe service. And it tells us our name of our pod, the name server's default, our labels. This is very important. If you mess up your labels, things get squirrely. Your IP address, which is the internal IP address and its endpoints. And to access it, we're going to do 8080. There's our console. So the console is now up. There's our Hello Minikube, our pod, so our container, our image, our deployments, our pods. Now, let's test our instance. So for this guy, since it's an echo, we'll do a curl minikube service hello minikube to execute our service and URL. And there it is. So the pod has no pod information available. Server, there's our server information. It's a get. So if I actually wanted to test this from our browser, I would copy that. This guy into my browser. 192.100. That should work. Oh, that's right. This is just the echo. It's still taking a minute. Sorry, not 8080. This one. So this is the internal and the internal port. We're mapping it here to the 30596. So this, when we did expose, this is how we exposed it. There we go. So we see the exact same information here, except now it's telling you your user agent is Mozilla. So far, so good. No real problems. So now we've seen it running. Let's clean up. So let's delete the service. And when you delete the service, it typically takes it a second or two to drop it off the monitor. And while that's running, so I've now essentially deleted the container. Now I'm going to delete the pods. And there goes the deployment, and the pods will take another second or two. Pod's still running. Trying to see if I can catch it. Managed to catch it closing last time. There we go. So as you can see, if something happens, if it errors or you get a warning, it'll change color. There, it's terminating. It's still terminating. And it's gone. So now we're back to our core cluster. And then when you're all done, you just do MiniCube stop. For time purposes, I won't stop that. I'll just keep it up and running. So next, let's open up Spring STS. Okay, here we are, Spring STS. So I have a little project here called GS Spring Boot Docker Complete. If you go through the tutorials, if you do a new import Spring getting started content, they have a Docker guide here. And if you do initial and complete, you can walk through the guide and start with the initial, which is a blank project, and then you can go through and input the pieces. Or if you want to cheat and just jump right to the end to make sure something works, you can take the complete, walk through the setups, and you have a fully functioning project, which I have here. Quick look, it's that little hello world. Look at our application. All it essentially will do is going to echo out to the browser, hello Docker world. This is just a very simple Docker application to make sure that our container works within our Docker environment, or in our case this time, Kubernetes. The other thing you need to do is you need to define your Docker file, which gives it its dependencies. So we're going to use OpenJDK 8. We're going to set our shared volume as temp, pass in an R jar files, copy the jar file, our app jar, and then set the entry point. So if everything works here, which it should, so we'll test it locally, run through Spring Boot. Spring Boot kicked off. We have a nice little Tomcat instance running. Click Open Browser, and there's Hello Docker Role, local instance 8080. So good. So this guy works. So we'll go ahead and stop him. Back out to our command line. Going to go to the completed version. And then we run the Maven install Docker file build. Compiles the project, runs the test file in the project, passes. Now it's building the container. And it will deploy the image to Docker. And if all went well, Docker image once. We have a Spring.js Docker or Spring Boot Docker image here, which we can now use for our Kubernetes. So now, back to my steps here. So now, back to my Docker folder. So now we need to create our Spring Boot Docker YAML file. I never pronounce that right. This is going to give us, essentially we have to build our deployment file. So this will deploy it to the cluster. So we go vim, Spring Boot. So in here, the first line is API version 1, number for the versions before 1.0, use apps VI beta 2. Kind, this is a deployment YAML. We have our metadata, so this is the name of our deployment, Spring Boot Docker example. Our specs, our selector, we're going to set the app name to be JS Spring Boot Docker. It's usually best to name it the same as your image. You can't use the slash or hyphen like you have here, but our image has to match what's in Docker. So it's spring.io/ds Spring Boot Docker. And you can specify your version by :version. I'm just going to grab the latest. I'm going to call it JS Spring Boot Docker, which is the name of the project. We're going to use the container port 8080. And we're also going to set replicas for, which is actually how we spin up multiple versions of our container. And so if I want to run 2, I could change that to 2. If I needed 6, 100, change that here. And labels, some more metadata information here. Really, the only things you're going to change with this file is you're going to change this name, you're going to update this name, tell it how many versions or how many replicants, essentially how large a scale do you want to scale this particular container, give it another label here, and specify the container information here. Now to install it, or essentially to deploy it to kubectl, we do kubectl apply -file.springboot Docker YAML. Okay, it says it's been created. So let's actually go look at the description of it. So if you do kubectl describe our deployment, and you specify the Spring Boot Docker example, that was our meta label for this deployment, we now get the information for our deployment. So here's our name, the default, some labels, when it was created, how many replicas are we running, essentially how many pods are we spinning up, 25% max unavailable, 25 max surge, so it's still bringing it up. Tells us our port 8080 and some other information. All right, so now let's go look at the actual pods. So we said kickoff 4, so we should see 4. And there we are. We have 4 instances of our container running. And let's get some information about this pod. So we can then take our name. And now we can actually dig into the pod. So what I did was, where'd it go? So we do describe pod, just like we did the describe deployment. So kubectl describe, you can specify the different things: deployment, service, or pod. So in here, our pod container, our container ID, what image is it running, what port are we running on, some additional information, our type secret, so there's our volume, and some other information. Now, as of right now, we can't actually hit this guy. This guy's essentially running in its own container and has not been exposed yet. So if I were to run kubectl expose deployment and then give it the meta for our deployment and tell it type node port, it will now expose our Spring Boot Docker example. Now let's go look at our service descriptor for this guy. This guy gives us our name, Spring Boot Docker example, our label. So if you notice, our name does not match our label. That's because we set the label to be the name of our image, our selector, our node. Here's the port locally to the container or to the pod. So on the pod, it's running 10.136.222:8080. However, to access this, we have to use our port, which is the IP, which will be this guy, :32528. But if I go to the console, oops. There's our IP address there. So we would take that. We have here, and our port, which is going to be 32524. Hello world, hello Docker world. So we definitely know that this guy worked. So our Spring Docker example has been deployed. It's the pods have spun up, and the Kubernetes cluster is running. So if we go look at our dashboard, back down. So you'll see here we have our deployments. We have one deployment. Within that deployment, we have 4 pods, or essentially 4 instances of our image deployed to that server. And we have spun up our service here that essentially exposes our internal endpoint to our external endpoint, the 32524. And we have our secrets here, so you can actually spin down into these, which is kind of cool. You can edit straight from the console. So like I said, anything you can do from the command line, you can also do in the console. However, at times, you can work either way. I find the command line tends to be faster sometimes, but if you have to do a lot of editing, then can be tedious, so you may want to come to the console here. So we've exposed it. So now, if we want to change anything, we could change it here within our console, or we can go back to our command line. And we can go vim, modify our deployment descriptor, and say I wanted one replicant. Change that guy. Just need to reapply the change. Give it a second. Usually takes it about a minute to dispose of the pods. Now, if I change this up, which is funny because it's actually faster, or you actually visually see this better if I actually go up. So if I say do 8 nodes, or 8 pods, reapply it. Now we have 8. But at the moment, you only see the 1 because I had 1, but then I kicked off 8. So you can see the different analytics. So hey, you got 1 pod running, 10 in flux. And now all 8 are running. When they're all done, it's real easy. All you have to do is clean up. So we just delete our service. It dropped it. And then we clean up our containers. See if I can catch it in flux again. And what you don't see here is if for any reason one of these failed, all you would have to do is drop it and it would automatically reapply the missing one. So since we've set it up for 8, if we dropped 1, reapplied, it would spin that back up that 8th pod. Like we talked about in the Docker presentation, essentially if your containers fail in this environment, it's essentially faster to get rid of the bad container and redeploy the image to a new container and reattach it to your cluster than having to go in and debug it. So this way you essentially have no downtime. If something breaks, get rid of it and restore it. And we're back to where we started. And then when you're all done, run MiniCube stop. And it will stop your local Kubernetes. Takes it a second or two. And it stops. If I refresh, it's going to fail because we've stopped the server. So let's recap. So we covered what Kubernetes is. Remember, it is an open source system for automatically deployment, scale, and management of containerized applications. We looked at the architecture. It's got a cluster of nodes. We've got images. We've got the communication of the UI and CLI tools to the Kubernetes to the API. We also talked about some of the ways you can learn Kubernetes, either online through Kubernetes Basics, Katacoda, or Play with Kubernetes. These are great online sandboxes if you don't really have the time or the resources on your local machine to actually play with Kubernetes. And then we walked through the demo of actually setting up a full Kubernetes development instance using MiniCube and the kubectl commands, and also looked at using the console, the web console, to actually monitor our containers. Leave you with a little quote here. Quality is not an act, it's a habit. Aristotle. And as always, we appreciate your time. Please follow us online at developernerd.com, Facebook and Twitter. If you have some additional questions regarding this lesson or one of our other lessons, please feel free to drop us an email at info@developer.com or leave a comment on this video or blog. Thanks again, and have a great day. Open for questions?
So can this be used to deploy enterprise applications, or is strictly for Docker systems?
This particular setup is for development. However, you can take that deploy file, that deployment script file that I showed you, and you can then push your image up to a production system and then essentially run that deployment file, and then it's live on the production system. If you go back to Docker, think of these as image files, or they're essentially micro VMs in a sense, but they're not. They're containers where they can be deployed to any system. So you essentially build them locally in your development environment, make sure they're stable, and then once you have everything essentially boxed and packaged together in your container, you can then deploy that container to any cluster or any type of Kubernetes type system, or Docker, or like AWS, essentially any system that is built to handle and deploy containers.